So in this video, we're going to be doing the Intro to LAN room on TryHackMe. The Intro to LAN room is the second room in the networking fundamentals path on TryHackMe. And this is all part of the cybersecurity or the pre-security path on TryHackMe. And it really just kind of goes through all the different things that you will need to know before you start diving into a lot of the cybersecurity content. This is absolutely fundamental stuff that you will need to know. It'll, if you don't understand some of this, then some of the more advanced concepts, might not make a ton of sense, or it might be harder to replicate. And so we're going through it right now. Previously, we hit the what is networking path or room. If that is something that you're interested in, definitely check that out on the channel. And then if you're interested in some of these other walkthroughs, stay tuned because those should be coming soon. Now let's go ahead and dive right in. Okay, so the intro to LAN includes 5 different tasks. We're gonna learn all about subnetting, ARP, DHCP, and then the OSI model. And we already have actually a video on the OSI model, but it's always good to dive back in because we like review, because we're nerds and we like to learn things. Now, local area network topologies. Over the last 10 years, there's been an experimentation and implementation of various network designs. In reference to networking, when we refer to the term topology, we're actually referring to the design or look of a network at hand. Let's discuss the advantages and disadvantages of these topologies below. So we're actually going to go through, we got a few different topologies here, and each have advantages and disadvantages. The Star Topology, the main premise is that devices are individually connected via central networking device like a hub. You can see that right here, graphically represented. It's most commonly found because it is reliable and scalable. You can add, you can just, beef this up and then just keep adding more and more devices. As it, and they mention it here, as it scales, more maintenance is required. And this is kind of like your critical node. If this goes down, all the devices that require it for networking are also basically taken offline. And so this is a critical point of failure that you'll become intimately familiar with. Remember that availability is an entire, part of the CIA triad. So it's not just from a security perspective. It could be from a, disaster recovery perspective. You want to make sure that that is up 24/7 so these devices are going to go, but also that it is secure, which is going to be, it can be a challenge. Bus topology. It relies on a single connection, which is known as the backbone cable. You can see that right here, and each device is hooked up to that backbone cable in some sort of way. Because all the data is destined for each device travels along the same cable, it is very quickly prone to becoming slow, and bottlenecked if devices within the topology are simultaneously requesting data. Now, this can absolutely happen, and it also depends on the strength of this cable, and how much data that it can actually handle at any given time. That's where like a denial of service attack can really come in. You're just like flooding this cable with requests, and some of them are getting dropped or lost, or they're just not making it to these endpoints. There's also little redundancy in place in case of failure. So the disadvantage because of that is a single point of failure along this backbone cable. If the cable were to break, devices can no longer receive or transmit data along the bus. So not fantastic. Sometimes you might, see this, but there are disadvantages to it. And then you got the ring topology, also known as token topology, both some similarities. Devices such as computers are connected directly to each other to form a loop, meaning that there's little cabling required and less dependence on dedicated hardware, such as within the Star Topology. So basically, they all kind of form their own network by being directly physically networked to one another. This works by sending data across the loop until it reaches the destined device. There's one direction for the data to travel across this topology. It is fairly easy to troubleshoot if any faults arise. You'll know if one of these devices go down and requests are no longer being forwarded. So let's say this device goes down, requests will come along the ring to this device, but they're not going to get forwarded. So okay, well, that's what I need to troubleshoot. Less prone to bottlenecks because they're, kind of going around the whole ring, but it is a double-edged sword because it's not an efficient way of data traveling across the network. Again, like for this device to reach this device, it has to go all the way around. So that's kind of a pain in the butt. So what is a switch? A switch is a dedicated device within a network that is destined, or excuse me, that is destined, that is designed, whatever. It is designed to aggregate multiple other devices such as computers, printers, or any other networking capable devices using the Ethernet. These various devices plug into a switch's port. Switches are usually found in larger networks such as businesses, schools, similar sized networks where there are many devices to connect to or on the network. Switches can connect to a large number of devices by having ports of 4, 8, 16, 24, 32, and 64 for devices to plug into. So both switches and routers can be connected to one another. The ability to do this increases the redundancy and reliability, or reliability, you can read it as, of a network by adding multiple paths for the data to take. If one path goes down, another can be used. Whilst this may reduce the overall performance of a network because packets have to take longer to travel, there is no downtime. A small price to pay for salvation. You're networking Thanos. Snap and the network is down. What is a router? A router's job to connect. It's a router's job to connect networks and pass data between them. It does this using routing, hence the name router. Mind blowing. Routing is the label given to the process of data traveling across networks. Routing involves creating a path between networks so that this data can be successfully delivered. So, I mean, pretty easy. Note that routers and switches are not the same. They are not the same. And I believe we'll back up and we'll look at that through the OSI model because there can be some details with the OSI model about switches too. So a little thing to surprise, or a little thing to be excited about. So LAN stands for local area network. Routing, that's a verb given for routers to perform. I know. What device is used to centrally connect multiple devices? Switch. Okay, yeah. What topology is cost efficient to set up? Who's the bus, right? Because it's literally bus topology, and it's cost efficient because you have like that central node or that central line, and you just need to hook it up to the line. Is expensive to set up and maintain. Star Topology. All right, now let's go ahead and check this lab out. This lab will take you through the flaws of different network topologies. In a ring, all devices are connected to, and this is actually, we've talked about this, but this will graphically represent it like I mentioned. So device goes down, cable goes down, cable. Okay, so let's go and cut it. So as you can see, requests are basically stuck at that machine. Nothing flows anymore. Bus topology, all devices are connected to the single backbone. So there you go. Now it's kind of saying that, again, you can flood this and cause some of those requests to get dropped. So let's go 5. And let's just flood it, right? We're just going to spam it and cause it to crash. See? We are agents of chaos. All right, so then for a star topology, all the devices are connected to a central switch, and every packet is sent to the device that it needs to go. So this is doing a lot of work, but again, let's say we're an agent of chaos and I just want to hammer that thing. Now the whole network is gone. So each one of these has their pros and cons. We mentioned that the star topology, although it is the most expensive, it's the most scalable. So if you can really, harden this device, and this is what most orgs will do, is they'll just harden the crap out of this device and secure it, then you'll be pretty fine on the network availability. But if anything were to happen to that central node, you're gonna have some issues. So let's talk about subnetting. Who doesn't love subnetting? Let me take a drink. So as you're kind of building this out, you're creating your own network, right? But you're going to want to go ahead and split these networks into logical segments. So like, let's say you have an accounting network, you have an HR network, you have a finance network, you might have an IT network, you might have a security team, you might have a lab, so you want to have all these logically segmented, not only just so it's, less congested traffic wise, but also so, let's say an attacker breaches someone in accounting, they're not able to access someone in finance without going through this switch. Or let's say, you beef up a lot of the security at this node, you'll be able to catch that kind of movement and lock it down. So all students send information in real life to the correct department. Networks need to know as well. And this is really where you're going to specify by subnetting. As we recall, an IP address is made up of 4 octets. We did that in the previous room. So if you haven't checked out the networking fundamentals or the what is networking room, definitely check that out because we do break these down, as well as IPv6 and MAC addresses. So basically they will use the IP address to be able to identify where to go. But these octets will actually identify a network. So you can do, like, let's say 192.168.1, and then the range under 1 is like your accounting, and then 168.2 can be your finance network, and then all those 255 devices are in accounting, or your finance network, blah blah blah. You continue to do that, and then that way packets are routed to the right area and they're not getting sent to the wrong network. So subnetting provides a range of benefits, including efficiency, security, and full control. Absolutely. So what is the technical term for dividing a network into smaller pieces? Subnetting. How many bits are in a subnet mask? What is the range of a section octet of a subnet mask? So let's go 12255. There you go, 0 to 255. What address is used to identify the start of a network? What address? The broadcast? No. Default gateway. That's it. Default gateway. Well, let's talk about the default. No, actually, let's review that because I got that wrong. Whoopsie. It says right here, I'm an idiot. Network address. The address identifies the start of the actual network and is used to identify the network's existence. For example, a device with the IP address range of 192.168.1.100 will be on the network identified by 10. So yeah, that kind of makes sense. So it's basically just the start of the network. Goof address. Yep. What address is used to identify devices within the network? Host address. And you can see that here. This obviously can change. Doesn't have to be 100. It really is just whatever is assigned. And what is the name used to identify a device responsible for sending data to the entire network? Default gateway. And you might recognize these as, well, no, I lied. 255 would be your broadcast address, and that kind of like fires stuff off to the entire thing. But anyway, our protocol. Recalling from our previous task, the device has 2 identifiers, a MAC address and an IP address. Again, check out the What is Networking video. The ARP protocol, or Address Resolution Protocol for short, is the technology that is responsible for allowing devices to identify themselves on a network. Simply, the ARP protocol allows a device to associate its MAC address with an IP address on the network. Each device on the network will keep a log of the MAC address associated with other devices. How does ARP work? Well, you get a request and you get a reply. So pretty simple, right? So when the ARP request is sent, a message is broadcast to every other device found on a network by the device, asking whether or not the device's MAC address matches the requested IP address. If basically like, hey, does this match? And then you'll get a response saying, yeah, I actually have it as this. If the device does not have the requested IP address, an ARP reply is returned to the initial device to acknowledge this. The initial device will now remember this and store it within its cache in ARP. So Address Resolution Protocol. What category of ARP packet asks a device whether or not it has a specific IP address? ARP something? It was a request. I have like goldfish brain sometimes. Nope. What category of request? Okay. What address is used as a physical identifier for a device on a network? MAC address. And again, if that doesn't make sense, check out the What is Networking video. We talked about that there. What address is used as a logical identifier for device on a network? IP address. DHCP. So this is the Dynamic Host Configuration Protocol. This is basically how, so let me just read this blurb. It would make more sense that way. IP addresses can be assigned either manually by entering them physically onto the device or automatically, and most commonly by using a DHCP, and that's Dynamic Host Configuration Protocol server. When a device connects to a network, if it has not already been manually assigned an IP address, it sends out a request, a DHCP discover, to see if any DHCP servers are on the network. The DHCP server then replies back with an IP address and device could use an IP address the device could use. The device then sends a reply confirming it wants the offered IP address. And then lastly, the DHCP server sends a reply acknowledging this and acknowledging that this has been completed, and then the device can start using the IP address. So this is literally, you have just joined the network. Hey, it's like, a player joins a football team. Hey, we're going to have you play with this number. Okay, fine. I'll play with that number. That's great. Good to go. So, hey, I'm new here. Can anyone give me an IP address? This is a really good graphic. Hey, sure. Here's the IP address for you. Yeah, perfect. That works for me. I'll start using that. All right, great. See you around. All right. So what type of DHCP packet is used for a device to retrieve? That would be the discover. DHCP type of DHCP packet does a device send once has been offered an IP address? That's going to be the offer. Ooh, nope. Big oof. Send once has been offered. Oh, that's going to be the request. See, I'm reading this a little too fast. Finally, what is the last DHCP packet to be sent? That's the ACK, short for acknowledge. So that is the LAN room. And the next thing that we're going to be doing is let me back out of this room and we'll take a look, see at what's next. Next will be the OSI model. And we actually already have a video on the OSI model on this channel. So definitely go check that out if you want some spoilers. But if you are, interested in that, stay tuned on the channel. I'll probably do another live stream at some point, kind of continuing these rooms. And then I'll break these up into individual walkthroughs as well, if that's interesting to you.